use the definition of partial derivative to compute f sub x for the function f of xy equals 3x squared y plus 5xy minus 2y minus 4. So we would like to compute the partial derivative of the function f with respect to the variable x, and the definition says that this partial derivative is a limit of a difference quotient where the difference quotient is going to have h go to 0, and in the numerator we're going to take the change in the function as x changes from some value x to the value x plus h. So that difference is f of x plus h comma y minus f of xy. So there's no change in the variable y, it's the same. The variable in the x position has changed from x to x plus h. So we have a change in x of size h, and we divide by h. So now the f of xy we have here, and we have to compute f of x plus h comma y. So let's do the algebra required in this numerator off to the side. So f of x plus h comma y. So in the two places here that we see an x in the original function, we will replace that x with x plus h. So this is 3 times x plus h squared times y minus 5 times x plus h times y, and then minus 2y minus 4. And so now we will expand this out, and here we will distribute the 5 and the y. So this is 3 times x squared plus 2xh plus h squared times y, and we'll distribute those next, minus, distribute 5y, so we get 5xy, minus, distribute the minus as well, 5hy, and then minus 2y minus 4, and distributing the 3y, this is 3x squared y plus 6xyh plus 3h squared y, and then minus 5xy minus 5h y minus 2y minus 4. So this is f of x plus h comma y. And so now back to our limit. In the numerator, we want to subtract from this newly discovered quantity f of x plus h comma y the original function. We would like to subtract the original function. So the original function has 4 terms, and this should have been a plus, and I made it a minus. That was a plus, that's a plus, that's a plus, and those are pluses. This was a plus. I wrote it down over here as a minus. So now everything is okay. And when we look at these terms here in f of x plus h comma y, there are 7 of them, and we should see these 4 terms exactly as they are among them. So let's just notice that. 3x squared y is here. 5xy is here. Negative 2y is here. And negative 4 is here. So when we subtract the original function from f of x plus h comma y, then these 4 terms will cancel out, and we will just get the remaining 3 terms. So the numerator simplifies to 6xyh plus 3yh squared plus 5yh. Just trying to be consistent here. I've scrambled up my y's and my h's over there. Here I put the y before the h. And dividing by h. So each of these three terms has an h. We can cancel that h with the h in the denominator after we factor it out. So we'll factor that h out. It'll be h times 6xy plus 3yh plus 5y divided by h. The h cancels, and now we are left with the limit as h approaches 0 of 6xy plus 3yh plus 5y, and when h goes to 0, the first and third terms are unaffected, but the middle term becomes 0 because it has an h. So 6xy plus 5y is our final answer. And if we look back at the original problem, the original function, calculating the derivative without the definition, we just treat the variable y as a constant. In our definition of f sub x, the derivative with the partial derivative with respect to x, the variable y is unchanged. So we treat the variable y as a constant, and then we take the derivative with respect to x. So if y is a constant, then the 3y is the coefficient of x squared, so 3y. And then the derivative of x squared is 2x, using the constant multiple rule, where we're including y as part of the constant and not just the 3. And here, 5xy, 5y is the constant, the coefficient of x, and the derivative of x to the first power is 1. And so you can see our answer here is 3 times 2 is 6xy, plus 5y times 1 is 5y, and that's what we have here. So a shortcut for calculating the derivative, the partial derivative, is to hold the other variable as constant. So partial derivative with respect to x, we treat y as a constant. So here the derivative of 2y, that's a constant, so that was 0. And of course 4 is a constant, and the derivative of that was 0.